So we will see binary search trees. We will see the following operations on a binary search tree. So these are two examples of binary search tree. In the first example, you can see that all the nodes on the left subtree of 6 are smaller than 6 and all the nodes on the right subtree of 6 are greater than 6, and this is true for all the nodes for a binary search tree. Like even for 7, 8 is greater than 7, and even for this subtree the right child has value greater than 5 greater than equal to 5, and the left child has the value 2 which is less than 5. I'm storing the greater than equal to values on the right subtree. Also in the second example, you can see, like, let us take the node having value 5. The right subtree has values greater than 5, and this is true for all the nodes. So this is the property of a binary search tree. So we will see in-order tree walk for a binary search tree. Suppose that we do the in-order tree walk for node X. If the node is not null, we basically do the in-order tree walk for the left subtree. Then we print the value of X, and then we do the in-order tree walk for the right subtree. And this is true basically because of the property of the binary search tree, that all the elements on the left subtree are smaller than that node, and all the elements on the right subtree are having values greater than that node. Now for searching, suppose that we are searching for the value k and x is the root. Then if x becomes null, we basically returns x, or if key is equal to the key that we are searching for is equal to x dot key, then also we return x. This is the base case. Otherwise what we are doing is that if k is less than x dot key, then we basically search for the k in the left subtree, because we are storing less than values in the left subtree, and otherwise we will search it for in the right subtree. And when x basically becomes null, like in this base case we are also having x is equal to null case, then basically that means that we have not found the key k, so we are returning null value in that case. Suppose that we are searching for value 29 in this tree. So firstly we will compare it with 41. It is not 41, so 29 is less than 41, so we move to the left subtree. We compare it with 20, so 29 is greater than 20 and it is not 20, so we move to the right subtree. Then we compare it with 29 itself, and this is equal to 29, so we basically return 29. To find maximum and minimum, let us see what we can do. Tree minimum, if we are having node x as the root, is basically that if x dot left is not null, we just keep moving left, and as soon as the left child becomes null, we return x. Tree maximum is also similar. Till x dot right is not null, we just keeps moving right. As soon as the right child becomes null, we just return x. So now let us see successor and predecessor, how to find them. Tree successor can be found in this manner, that if x dot right is not null, then we basically return the tree minimum of x dot right, because the tree minimum value in the x dot right, the right subtree, is basically just greater than that value, the minimum value that is just greater than that, so we are returning that. And if the right child is null, that means that we go up the tree and we found a node that is the left child of its parent, and we return that node. So now let us see the example of this. Let us see an example of how to find the successor. Suppose we want to find the successor of 41. In this case, the 41 right subtree is not empty, so we will basically find the minimum value in the right subtree, which is 50, and 50 is the successor of 41. Suppose that we want to find the successor of 32, and 32 has no right subtree, so we will move up. So as we move to 29, 29 is the right child of 20, so we will move again up. So 20 is the left subchild of 41, so that means that we have to return 41. 41 is the successor, so we basically move up this path, and as soon as we find a path turning this way around, like this is the left child of its parent, so we return its parent, which is 41 in this case. Predecessor can also be found in a similar manner.